You cool cats and kittens, little reference for you if those of you have watched that show that I'm referring to. This is only take number 4, so let's see if we can do it this time. I think I'm just going to work through it. If I mess up at all, you guys are going to have to deal with it. Sorry, I mess up in the class all the time, so I don't know why I'm trying to make this so perfect. But anyways, I'm going to put my sunglasses on because we have the sun with us today, aka 4 lights because it's bright. And then the Earth is going to make an appearance here in a second. Get excited, I know. So we're going to talk about how the Earth moves and what that causes here on Earth, where we live. So the very first thing we're going to do is we are going to pretend like we take here's my Earth, a dog toy, here we go, and we're going to stick a line right through the center of it. Okay, and so then it would be like this, a line going all the way through it. You get the point. So imaginary line, it's not like you take a picture of the Earth and you see these lovely two, sticks sticking out at the end of the Earth. It's imaginary. But that is where, so this is where our North Pole is, and this is where the South Pole is. We actually have 2 North Poles and 2 South Poles. I'll get to that on the next slide. But the axis is going to run right through the middle of it. So you'll notice that the axis is not straight up and down like this. It is on a tilt. All right, we're at a 23.5-degree tilt if you want to get technical. But we are on a tilt, which is going to cause something that we will talk about a little bit later. But the rotation basically just means it spins on itself. All right, so if you would get up and just literally spin in a circle around and around, I would get up and do it, but there's limited space behind me since we're painting our house and everything is on top of me right now. But if you would just spin in a circle, that's a rotation. So that is going to cause, so if this lovely, we'll go with this orange spot. So this orange spot, when this orange spot is facing the sun, it's daytime over here, and then as it moves away, that's a new orange spot. There's too much orange on this. And it's in the back, now it's nighttime. So whatever side of the Earth is facing the sun, so obviously it's about 5:30 right now, so we're starting to move away, we're starting to rotate away, so soon it'll be dark and we'll be in our nighttime phase. And then the other side of the world will be in daytime. So that's how we get day and night, and that's one movement we do. So we complete a rotation every 24 hours, and that is day and night. So how many rotations does Earth complete a year? Say it out loud. I should be like Dora. Should I stare at you and wait for you to answer? How many rotations does Earth complete in a year? That's right, 365. I don't know if you said it or not, but we're going to protect you, Dave. Next slide. I'm going to take my sunglasses off. They're a little too much for me to handle right now. So like I was talking about, because of this magnetic field that we have 2 North Poles. You have what we call the magnetic North Pole, which if you had a compass, that is what that points to. So whenever your compass points north, that is pointing to the magnetic North Pole. So that would be this dotted line over here that you see in this picture. And then this one, the tilted one, is going to be the rotational North Pole. That means that's what we rotate on, but that's also the true North Pole. So that's where we deem this is the North Pole. That's where Santa Claus lives, right here. This is the South Pole. This is the magnetic one. So notice that there's a difference because of the tilt. So if you ever go out with a compass, which I'm so sure so many of you own, and you just want to walk north, eventually you would just get to this point. You wouldn't actually get to the true North Pole because the magnet and compasses are going to lead you here. Okay? I doubt any of you own a compass. So we'll move on from that. The other movement that the Earth does, so we have spinning, spinning, spinning. This is a rotation. And then not only that, then it is going to do what we call a revolution. So it is going to spin, 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 and then it's going to also revolve around the sun. So it's doing 2 different things. And you can see here, we're going to talk about this on the next slide as well. But you can see here, because of this tilt, you can see during the month of like June, July, August, when we are on this side of the sun, North America, aka where we live, is pointed or leaning towards the sun. So if we're North America up here at the top of the pen and this is South America down here, during the summer we are like this. we're leaning towards the sun. And then we would move around and we would go to fall. So you can see with fall, that is where neither North America or South America are leaning towards the sun. But then if you look at our December, that is when we are leaning away from the sun. So even during our daytime, we're still leaning away from the sun, so we don't receive as much direct sunlight as we would during these months over here. I don't know why I just pointed at the camera. Okay, got it. Okay, there we go. During these months over here in June, July, and August, when we're pointing towards the sun, we're leaning towards the sun. So during the fall months, so over here, and during the spring months over here, we're not leaning towards or away from the sun. That's when we're just chilling out right there with it. But during the winter months and during the summer months, we're either leaning towards the sun during the summer, and then we're leaning away from the sun during. Did I say that? We're leaning towards the sun during the summer, away from the sun during the winter. I don't know what I said. Like I said, we're not going back on it this time. This revolution around the sun is not a perfect circle. It is what we call an ellipse. So it's kind of like an oval shape. And so the sun will actually, not the sun, the earth will actually get closer and farther away from the sun depending on where it is in its revolution. This has nothing to do with your season. Everybody thinks like, oh, it's summer, so we must be right here next to the sun. No, okay? The distance from the sun to earth has nothing to do with the season. It is all about the tilt of our axis and the revolution. Nothing to do with how far we actually are away from the sun. So please do not think that just because we are closer to the sun, it's going to be summer, because that's not true at all. Okay, so the seasons, like I was just talking about, and you can see here in this picture as well, because of our tilt, and this would be us going around the revolution. So as we move around the sun, we are either going to be leaning more towards it, or if we were over here, you can see that the top of my hand is now leaning away from it. Again, this would be a lot easier if I was in class with you, but we've got to make do with what we have. So when we are leaning towards the sun, I just spit. I don't know if any of you guys could see that, but it went. Anyways, when we are leaning towards the sun, that is when we are going to have longer daylight hours. So rather than it being split like 12 and 12, we are going to have about 16 hours of daylight and then about 8 hours of nighttime, which is all what we like. We like that. Sun rises early, sets later. We're happy people. Then in the winter, when we're over here, because of that tilt, even when we face the sun, we're not receiving those direct rays. And then when we rotate, we get out of the sunlight faster, which means we go into nighttime quicker. So that's when it's going to be reversed. You're only going to have about 8 hours of daylight and about 16 hours of nighttime, unless you live in Alaska. Now they have extremes. So since we're going into the summer in the northern hemisphere right now, they are about to have about 23 hours of daylight because they are so far north. They're like all the way up here. They're about to have 23 hours of daylight. So even when they rotate, they're still getting a lot of daylight. And they're about to have just 1 hour of nighttime. Complete opposite in the winter, though. They only have about an hour of daylight, and then 23 hours of their day is in the dark. So if you can stomach it during the winter, then it might be a cool place to live during the summer, but you better buy some blackout curtains. So again, the lean of our axis causes the seasons. And then as we revolve around the sun, it's the combo. It's the lean and the revolution, okay? Nothing to do with how close or how far we are away from the sun. Solstices are kind of fun days. Well, one of them is super fun. The other one, not so much. They are the longest and the shortest days in terms of sunlight. So the winter solstice is going to be a pretty depressing day, at least in my mind. That's the shortest day of the year. That means that is when we are going to get the least amount of sunlight. That's in December. It depends on whether it's a leap year or not. That's why there's different dates there. And then it's right around Christmas time, but that is going to be the shortest day of the year. The good news is once you get to that point, every day after the winter solstice is going to get a little bit longer. And by a little bit, I mean 1 to 2 minutes. So we're not experiencing this great big change because it takes us 6 months to get from the winter solstice to the summer solstice in June, which is the longest day of the year. So we are about to, well, we're not about to, we still have a couple months, but in June, again, it depends on some stipulations like a leap year and other things like that. But in June, when we have the summer solstice, that is when we're going to have the longest day of the year. After that day in June, our days get a little bit shorter each day until we get to December. And then we hit that short day in December, and then they get a little bit longer until we hit the day in June. And then we get smaller again. Okay, so that is why our daylight fluctuates. So those are going to be completely opposite for the southern hemisphere. So we are going into summer right now. The southern hemisphere is actually going into winter. So in December, for the southern hemisphere, that is their summer. So Santa Claus does not come in like a big old red suit. He comes in like a bathing suit. And Mrs. Claus has her little bathing suit on too. They're not coming around in their, big wool cool coat and things like that because it's the middle of summer in December down there. Then we have something called equinoxes. Equinoxes, they sound like the word equal, and that means you have equal daylight just about. So you've got about 12 hours of daytime and about 12 hours of nighttime. That's going to happen in between your two solstices. So we have a solstice in the winter, and then we hit our spring equinox, which we just had in March. And that means that we've hit that mark now. Our days have been getting a little bit longer ever since December. And in March, we hit that mark where the daytime is about equal to the nighttime. And now we're getting even longer. So we're in the part now where our daylight hours are just a little bit longer than our nighttime hours. And then when you hit that summer solstice, then you're going to be working towards the fall equinox. So we'll have that equal time period again, but then after that, they'll get shorter and shorter until we hit the winter solstice, and that's the shortest day of the year. Again, these are all opposite for the southern hemisphere. So South America, Africa, Australia, they are all heading into their fall. No, they're not heading into it. They just had it. We just had our spring equinox. They just had their fall equinox, and they are heading into winter. So for all you Game of Thrones, winter is coming for them. That is all I have for today. These Google Slides will be posted on Google Classroom. You can refer to them. You do need to do a little check for understanding. It's a Google form. So do that today. And then Tuesday, Wednesday, Thursday, you will have an assignment that is related to what you learned in here. So refer back to the slideshow whenever you need help. Okay? See you guys next time. I know you're excited. I am. Bye.